on that. All right, so we're starting with linear equations, okay? The first 4 slides are just a bunch of lists of verbal expressions representing mathematical expressions, okay? Or X and Y are just representing some numbers, okay? I'm not going to spend a whole lot of time going through this whole list. You should have been seeing these at some point, hopefully in the last few years. They're mostly pretty intuitive. If English is not your first language, I would take some time to go through this list, okay, and make sure that you're familiar with some of this terminology. Sum of a number and 7 being addition, increased by is being addition, sum of 2 numbers. Same thing with subtraction, decreased by, subtracted from. Notice the difference between a number decreased by 12 and a number subtracted from 10 and how that changes the order of the numbers. Paying attention to those. Also got lists for multiplication and for division. Okay, these are common phrases that you'll see, and a lot of times these phrases are represented in application problems. So being aware of that list and being aware of those terms, so that when you see them, you have an idea of what they mean. So we're going to do 3 applied problem examples today. I'm going to give you kind of a general outline of approaching these problems. First and foremost is you have to read it. It's the hardest part, really. Read the problem. Read it a couple times if you have to. And identify what it is you're solving for. First and foremost, you need to figure out what does the question want. If you don't know what the question is asking you to solve for, then you won't be able to do jack squat. Right, AJ? You good? Yeah.
Hey, what's the code?
It's 284.
Can I have a whiteboard?
Now you can have paper. Once you've identified what the question's asking for, usually that's what your variable is going to be. Okay? And you can use whatever letter you want. A lot of people default to X because X is kind of the most. But you can use whatever letter you want depending on the problem. You can use T to represent time, or D to represent distance, or M to represent money. I don't care. Use whatever variable you want. But make sure you know what that variable represents. Sometimes you're going to have more than one variable. You need to be aware of what those variables represent. Write an equation using those variables to model the situation, solve it, and then most importantly, does your answer make sense? Okay? You need to take the extra 10 seconds to ask yourself, does your answer make sense? If you're trying to find out how long it takes to fly from Florida to California, and you get an answer of 45 minutes, does that make sense? No. It'll take you way longer than 45 minutes to fly across the country. And if you get that answer, it means, hey, I messed something up. I either wrote my equation wrong or I did a calculation wrong. Something happened. And you need to go back and address it. And you need to fix it. Okay? Don't just get an answer and assume it's right and then just move on with your life. That is the great thing about word problems. Okay? It's like, oh, word problems are the worst. Actually, they're better than non-word problems because they give you a context for your solution. They give you a way to check and see, do I have the right answer? Or do I at least have an answer that makes sense? So, starting with this one, we have the length of a rectangle is 5 centimeters more than the width. The perimeter is 5 times the width. What are the dimensions of the rectangle? Belle, do you have a question?
Oh, I just know.
Well, I'm going to ask some questions first. So thank you. Appreciate it. All right. First, what are some important words or phrases in that problem that I should highlight? 5 times the width. Okay, that's good. 5 centimeters more. Okay, that's a really big one. Let's pause on that one for a second. How do I find the perimeter of a rectangle? add all the sides. Okay? So I have the length plus the length plus the width plus the width. And then our shorthand, if we combine like terms, perimeter equals 2 times the length plus 2 times the width. Okay? So now I have a formula. I have a foundation and a starting point. You have a question, John?
Yeah, can you show like the light on
I shut up. I'm not going to shut up. So I now have a starting point for my equation. Now, if I don't know what the length specifically is or what the width specifically is, there isn't a whole lot else I can do with this unless I can look at some of these other things and do a substitution. Okay? So the length of the rectangle is 5 centimeters more than its width. So length, how could I write that as an algebraic expression? 5 centimeters more than the width. 3 plus 5. Okay? Let's see if I can make that 5 look less like an S. Alright? 5 times the width. Perimeter is 5 times the width. So perimeter is what? 5W. 5W. So now I have two things here that I can use to substitute into my formula. Okay? So instead of having 3 different variables of which I don't know anything about, I can now substitute length with 5 plus W because I know the length is 5 more than the width. I can substitute perimeter with 5 times W because it's 5 times the width. And then I can rewrite the equation using that substitution. Now, instead of 3 variables, of which I know nothing about, I have 1 variable. And when I have 1 variable, I can solve for that variable. So what do I do first? Distribute. Next, combine like terms. Next. Okay. Now my width is 10. So now I know my width is 10. Okay, so I found one of the dimensions of my rectangle. I have a width of 10 centimeters. So width is 10 centimeters. All right, am I done there? What else do I need to find? I need to find the length. It didn't ask for the perimeter. I could find the perimeter, but it doesn't ask. It says the dimension. So I just need the length and the width. Okay? So I know my width is 10 centimeters. What can I do to find my length now? Add 5. Add 5, because it says right there. The length is 5 more than the width. So, add 5, get 15. My length is 15 centimeters. Right? So it takes some just breaking it down. Alright? Do I wish I could show you an example of every single type of problem that you might see? Yeah, I do. Do we have time for that? Not even a little bit. Okay? But I can show you enough of the different types of examples that you can apply the same reasoning. Okay? But again, the hardest part comes with you just got to read it first. Okay? Once you take the time to read it and work through it, and it may take you reading it 3, 4, 5, 6 times until you get all the pieces that you need, and that's fine. But read it, think about what it means, and just start working through it one step at a time. Identify, hey, I got a formula. Okay? How can I model this scenario? What can I fill in? What do I know? What do I not know? What am I trying to find? Questions, comments, concerns, queries? Nate, how you doing back there? Good. This right here? Yeah, that's the formula for perimeter. 2L plus 2W, 2 times the length plus 2 times the width. That's the whole, like, we're adding up all the sides. Any other questions? Okay. Now, Next. Lots of words. Lots and lots of words. Pick out the important ones. For the 2005 baseball season, Major League Baseball leaders in runs batted in were Andrew Jones of the Atlanta Braves and the National League, and David Ortiz of the Boston Red Sox. In the American League, these two players had a total of 276 RBIs, and Ortiz had 20 more than Jones. How many RBIs did each player have? So, what's my important information in this problem? Okay, so 276. What about 276? Makes it total. So it's a total of 276. And then Ortiz had 20 more than Jones. So when I'm finding a total, what am I usually doing? Adding. Okay, so I'm adding two things up. What am I adding in this case? Say that again. RBIs of who? Two baseball players. So Ortiz and Jones, their RBIs have to equal my total of 276. Okay? But right now I've got three variables. Alright? Now, just like we did on the last problem where I had length equals a thing and width equals a thing, okay? We can do the same thing. When I wrote that length was 5 more than width, what I did is I took length and I defined it in terms of width. I said this is my length relative to the width because I have more information about the width, so I'm going to compare it to the width. I can do the same thing here with Ortiz and Jones. For one of these, I can define it in terms of the other person. I can define one of them in terms of the other. How could I do that? J is equal to O plus 20. So Jones is Ortiz plus 20. AJ? So Ortiz is Jones plus 20. Ortiz has 20 more than Jones. Ortiz has 20 more than Jones. Okay? So, I mean, but it's important. Look at it and make sure it makes sense. That's what the context is there for. So, you may have the right numbers, but you might have them switched as to who it goes to.
Well, I do have it right. I just said it weird.
Okay. All right, that's fine. That's fine. Not a big deal. So, Ortiz is in terms of Jones. Okay? Jones plus 20 gives me Ortiz. All right? Now, what I'm going to do is I want to break this down into one variable. So what I want you to do is I'm using the variable x. X represents Jones. Okay? If it would go. I'm trying it again. Alright? So I'm just using the variable x. That's it. Just the variable x. I want you to tell me which one best models the total of Ortiz and Jones. Okay? Which one of these best models that total? Total RBI. determined that if we take Ortiz, or if we take Jones and add 20, we get Ortiz, okay? So that's Ortiz right there, Jones plus 20. We add Jones again, and now I get my total. This is just saying that if I add Jones and 20, then I get my total. No, I have to include Ortiz as well. I have to have both, okay? Remember that we're adding both of them together. The X plus 20 represents one of the players. The X represents the other player. Okay? So now using that, what I want you to do is tell me how many runs did... Yeah. How many runs Jones... Yes. How many runs Jones had? Jones had. No, just the answer. Just the number. How many runs Jones had? How many runs did he have? Give me the number.
And I did it differently.
Bro, I was
I got it right.
I got
There's some
127.
variations.
9 people.
Oh, I got 127.
I'm going to assume the division was messed up. That's where I'm going to guess the mistake was. Okay? What's the first thing I do to simplify the left side of my equation? Combine like terms. I have nothing really to distribute. This parentheses is just there to indicate, hey, this is Ortiz. Okay? So this is Ortiz, this is Jones, but there's nothing to distribute. So combine like terms. 2x plus 20 equals 276. Subtract 20. 2x is 256. Divide by 2. That's where you get your 128. Okay? So that's how many runs Jones has. Okay? That's the number of runs Jones has. Now, using that information, how many runs does Ortiz have? Jones has 128. How many runs does Ortiz have? How do I figure out how many Ortiz has? Add 20. Ortiz has 20 more than Jones. So once we know Ortiz, or once we know Jones, add 20, then we get Ortiz. Okay? And then make sure that you compare, identify, okay, you get the right numbers, it's easy to mix them up. Actually, who should have more runs? Okay? Then make sure that's the one who has the most. Okay? And make sure there's a difference of 20. Alright. This one's quick. What is 125% in decimal notation? What is 125% in decimal notation? 125% in decimal notation. Yeah. Yeah, go ahead. there you go. See, you did better. 1.25. Okay, make sure you can properly convert your percents into decimals because I can't do math with percents. It has to be in decimal notation. All right, so we're going to end with this percent problem. 187 is 125% of a number. What is that number? Let's break this down. 187. Let's try that again. 187.5 is, mathematically, what does is represent? Equals. Okay? So 187.5 equals. Now turn that into a decimal. Of. What does of represent? Sometimes, in this case, what's the other option? Multiplication. Okay? Percent of something is always going to be multiplication. Percent of something. Okay? Of, multiply, and then some number. What do I use for some number? X. Okay? Or N or P or Q. I don't care. Some variable. Okay? So finding that number. Now how do I find that number? Divide. Divide both sides by 1.25. Thanks, L-Bands. Boom. Done. Okay? So that's when those mathematical phrases come in handy. Being able to convert a sentence like this. Okay? And sometimes it'll show up in word problems that have more detail, but the concept is the same. I want percent of a number. I'm multiplying a percent by something to get a result. Sometimes you're finding the result. Sometimes you're finding the original number. Okay? But being able to write the expression is going to help you determine, hey, do I need to multiply or divide? Okay? Because depending on which way you're going, it will determine the multiplication. Okay? Any questions on percent of a number? Rock stars, all y'all. Now, that's the section